This is Algebra 2 with Trig, 5A.2a. We're working on properties of rational exponents. You've learned these properties before, but how to deal with them with fractional exponents is sometimes a challenge. So what we're looking at here is a property that we're already aware of. Our bases are the same, so when we're multiplying bases that are the same, we add exponents. So AM times N. You add them. So let's add them. M plus N. Well, when we come over here with fractions as our exponents, it's not any different. This is 1/2 plus 1/3. So how do we add 1/2 and 1/3?
Common denominator.
You need common denominators.
Oh, yeah.
So when you look at your denominators, we have 2 and 3. What's our common denominator going to be?
6.
So for a 3 to become a 6, I have to multiply it by 2, so I have to multiply the top by 2. That means I'm multiplying this fraction by a value of 1, which isn't going to change its actual worth. This first fraction, we're going to multiply it 3 and 3, because 3 times 2 makes 6, so whatever I do to the bottom, I have to do to the top. So that gives us 3 over 6 plus 2 over 6, which can now be added, because we have common denominators, 5 over 6. Here we're raising a power to the power. So what we do here is multiply the m and the n. So here, when we're raising our exponents, they just happen to be fractions. We are going to multiply. And how do we multiply fractions? You don't crisscross. That's if it's a proportion. But you do go straight across. So 1 times 1 is going to be 1, and 2 times 3 is going to be 6. Here we have an exponent going into parentheses that have a monomial. This is not a binomial. This is not x plus something. This is x times something. That's okay to distribute into. A to the m, b to the m. So in this case, you can do x to the 1/3 and 8 to the 1/3. We're going to break this up into 2 separate problems. Now, what is 8 to the 1/3 power? Well, you know that 1/3 power means the cubed root, 1/3. The 3 is your denominator, that's your index. So 1/3, the cubed root of 8 is 2. So the cubed root of 8 is 2. Or you could write this as the cubed root of x. Whatever your denominator is your index. That's what the lesson we learned in the past. So now we've simplified that concept with a number that we could reduce it to, but we can't reduce the x. This is a negative next to the m. So if you have a negative exponent, that means you're going to write it into the denominator, but it's going to be positive. Well, we do the same thing here. That's x to the 1/2 power, but it's in the denominator. 1 over x to the 1/2 power. Or you might write it as your denominator is a 2. So we write a radical. We don't typically write a 2 because that implies it's a square root. We don't need the 2 because the symbol itself would represent a square root. Now, this isn't really appropriate to leave either. We shouldn't leave a radical in the denominator. But for right now, that'll be all right. We'll have to rationalize that in the future. Here we have the same base, but we're dividing. And when we're dividing, we're going to subtract the exponents. So to do that, that's going to be y to the 1/2 minus 1/3. So to get our denominators the same, I'm going to have to multiply this one by 2 to the top and the bottom, and this one by 3 to the top and the bottom. That's going to give me y to the 3/6 minus 2/6. So 3/6 minus 2/6 is going to be 1/6. Don't reduce those fractions. That's back to where you started. You can't subtract those without common denominator. Okay, here we have a fraction with our exponent. You've learned this one before. We distribute that exponent in. So it becomes a to the m power and b to the m power. Well, we would do that here. X to the 1/3 power and 8 to the 1/3 power. Well, what is 8 to the 1/3 power? That means the cubed root of 8. You can try it in your calculator. The cubed root of 8 is 2. So that would be either x to the 1/3 power, or you could say the cubed root of x over 2. Now, if the question was written with a fractional exponent, it's typically best to leave your answer with a fractional exponent. If your question was written with a radical, it's probably best to leave your answer with a radical. So if you're trying to decide which way you should leave it, if the question's written with it, leave it with that. All right, here we have a radical with an index with multiples inside, or factors inside. So we can break it up into those two factors. So in this case, we're going to do the cubed root of 40, and we're going to do the cubed root of x to the 5th. Well, how does 40 get broken up? You can do 4 times 10, makes 40. You can do 5 times 8, that makes 40. You could do 2 and 20, that makes 40. Your choice on how you want to do those. Why is it a good idea to use 5 and 8? 5's broken down all the way, and 8 is a perfect cube. That makes sense? Do you see how this is a cubed root? You might want to look underneath the cubes and see, do any of these numbers, are any of these numbers factors of 40? 8 is a factor of 40. So it's good to use the 8 because that's the cubed root of 8. And you don't have to work with 2 and 10 and then try to figure it out. Or 2 and 20. Anyway, this is going to become the cubed root of 8, the cubed root of 5. I don't know the cubed root of 5, so that's going to stay in there. How is this going to be broken down? What does that mean?
Can you minus it?
We have x, 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 x. We have 5 different x's in that. So I'm going to circle 3 of them. And that's going to bring them to the outside. Then I'm going to have the cubed root of x squared on the inside.
Wait, what? What's the inside?
This is the cubed root of x to the fifth. So I do have 5 x's on the inside. So I'm looking for 3 of a kind because this is a cubed root. So when I circle those 3's, I can bring it out. That means I have 2 x's left inside. So you would ask, can you subtract them? Kind of. By subtracting the 3 from the 5, that means you have 2 left over. You have 2 left inside. So my final answer is 2x, the cubed root of 5x squared. This seemed a little complicated, probably more complicated than it has to be, but we broke it apart into numbers and variables. We worked on the numbers, then we worked on the variables, and we combined it together. Numbers on the outside multiply together, numbers on the inside multiply together. Here, in the same format, here's a radical. This is a radical of a fraction. So we can break that fraction up into the 2. So we're going to do that over here. This is the cubed root of x, and it's also the cubed root of 8. Well, I know what the cubed root of 8 is. So I just have the cubed root of x left over. So let's go ahead and try to simplify these. What do you see? You have to make some decisions on these. This is the cubed root of 125. So this is cube root. Can I go to cube root? Do I have 125?
It's 5.
Hey, so it's 5. So the cube root of 125 is 5. The cube root of 8 is 2. So my answer is 10. It's not 7. Don't add them together.
6 plus 7
Second one here. Do you see how our indexes are the same?
Yeah.
If your indexes are the same, if it's helpful, it's not always helpful. If it's helpful, then you can write this as 1 fraction. That's kind of this rule written backwards. You can go from a single fraction into 2 separate radicals, or you can take 2 separate radicals and convert it into 1 radical with a fraction. Well, how many times does 3 go into 96? And what is the 5th root of 32? That's 2. So that worked out pretty nice. So 104. A good thing to do, if possible, is this is the cubed root. Cube root. Do any of these numbers go into 104? Okay? You may not be sure. If you're not sure, that's okay. Let's take a step here. So, the cubed root, how does 104 get broken down? It's an even number. So 2 times 52. Right? 2 times 52 makes 104. That's not 3 of a kind. 2 times 2 times 26. Well, that's not 3 of a kind. 2 times 2 times 2 times 13. Ah, there's my 3 of a kind. So 8 times 13. So the 8 could have been the number I used. But I wasn't aware of that factor, so I didn't use it. It doesn't matter if you notice it or not. You can just break them down.
Wait, so we can't use a calculator?
So looking under the fifth root, 96. Do any of these numbers go into 96? 32 goes into 96. So it might be best if we use 32 times what number? 32 times 2 is 64. 3 times 3 is 9. 3 times 2 is 6. So 96 times 3. What is the fifth root of 32? 2. So I'm going to use my fifth root of 3. The fourth root. Are there any numbers in the fourth root column that go into 162? 81? How many times does 81 go into there? 2 times. So 81 times 2. So what is the fourth root of 81? So we have the fourth root of 2. Now our last few questions. Notice these. This is kind of like 7x minus 1x. What is 7x minus 1x? 6x. It's not just 7. You don't just minus the x's away. This is 7x's minus 1x's makes 6x's. Well, that's what we have here. We have 7 fifth root of 12 minus 1 fifth root of 12 gives me 6 fifth root of 12. That's all you can do there. Because you don't have 5 of a kind in 12. How about here? Notice they're not the same. So you can't do anything directly with that.
You could like do like a
27 times 3. 27 times 3 is 81. Minus 8 times 3. That makes 24. Do I know the cubed root of 27? Do I know the cube root of one of these numbers?
2.
The cube root of 8 is 2. Do I have my radicals the same? 3 minus 2? Nope. Because you're not doing it to both sides of an equal sign. That's right. Okay, last one. The fourth root. 5 goes into this 81 times. 5 goes into this 16 times. So the fourth root of 81 is 3, so that's going to multiply the number I have on the outside. Fourth root of 16 is 2. Are my radicals the same?
Yes.
So outside, they don't get added together, they get multiplied together. So that's 8 fourth root of 5. Good job.